Good morning, everyone. We are continuing our special angles part of the circles unit, and we're going to get into the very specific type of angles other than central angles. So we started with central angles where the angle was directly at the center of the circle. The vertex was at the center. So that's the first one here. And this one was very straightforward. The relationship was very easy to remember because the measure of the angle is equal to the measure of my arc, which here on my picture, it's in purple. So the measure of the arc. Okay? So those measurements were equal to each other, only because the vertex was at the center. Today, we're going to move on from that and explore different angles that aren't actually at the center of the circle. And they're going to require very specific formulas that we're going to be using to find those values that we have. So the first one is called inscribed. That is called inscribed because the vertex is on the circle. Where's the vertex? On the circle. Not in the center, not outside, not inside, on it, right there. So that formula is going to be 2 times the measure of the angle, okay, because remember we have an angle and we have an arc. So 2 times the measure of the angle is equal to the measure of the arc. That is the formula for an inscribed angle that's on the circle. Inscribed. And I have this picture here. See the angle? This is the angle, and this is the arc. So 2 times the angle equals the arc. Okay, the next one. Outside. An outside angle is when the vertex is outside of the circle. So see how it is out here? It could be here, 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 anywhere outside of it. And that's going to create the angle, and it's also going to create an extra arc on the circle because we're used to just having one, right? For these two, there's only one arc that is created. But the next 2 types of angles create 2 arcs. So we're going to call this the little arc, and we're going to call this the big arc. It's always going to be one or the other. There's going to be a big one, and there's going to be a little one. And then you have your angle. So 2 arcs and 1 angle. And for this formula, it's going to look a little similar, but it's going to be 2 times the measure of the angle, again, is equal to the measure of the big arc. So the measure of the arc, and I'm going to put the word big here at the bottom. The measure of the big arc minus I used green for my little arc. The measure of the arc that is smaller than that, so the little arc. Okay, and in your problem, one will be smaller than the other, so you would be able to tell the difference, okay? So that is the formula for when the vertex is outside of the circle, okay? Now, inside the circle, this looks very different because it kind of looks like I have 2 angles, okay? But I don't. My angle is only 1 angle here. And this green part is not an angle. That's an arc because it's on the circle. So when my vertex is inside the circle but not at the center, right? It's not at the center. It's somewhere inside but not at the center. It creates a big arc and a little arc as well. And your angle is here, okay? So this formula is fun because it's exactly similar, not the same. So it's similar to when the vertex is outside of the circle, but the biggest difference is that you don't subtract the little arc from the big arc. We add them together. So they get added. So please write this formula down for when the angle is inside the circle. The vertex is inside. All right. So in the next video, I'm going to go over how to use these formulas. So make sure that you watch that. This is just your formula organizer. And then I'm going to do the next video going over one of each. Okay, so watch the next video. Thank you.